Kirchhoff current law its name itself indicating this law is all about currents, and we know that current is nothing but q by t and or nq by t. That is number of charges passing through area for a given time. That is the current flowing in any wire or any conductor. It depends upon the number of charges flowing through unit area. That's why KCl is also called as a law of conservation of charge. The conservation of charge means the charge is conserved. That is, number of charges coming from the supply, that is battery or a cell, is taken by the loads. That is, incoming charges is equal to outgoing charges. Okay, this is called law of conservation charges. Here, if you observe, this is the node. At node I1, I2, two currents are coming towards the node, and I3, I4, these two currents are going away from the node. By simply observing this diagram, I is nothing but number of charges flowing for unit time. Okay, due to this current, there is some charges. Due to some charges, there is other current. The number of charges coming towards this node, the same amount of charges going outside of charge. That is, Q in is equal to Q out. Number of charges incoming is equal to number of charges outgoing. Okay, the Kcl statement is at any node. In this case, we are taking x. That's why at node x, sum of incoming currents is equal to sum of outgoing currents. As always, obviously. Otherwise, the statement we can write as the algebraic sum of currents meeting at a node is equal to 0. That is, this I out, if you come to left side, I in minus I out is equal to 0. This minus indicate that the current which are going outside of the node is exactly opposite to the direction of the current which are coming towards the node. That is simple. See here, I draw a circuit, simple circuit, which contains 3 resistors and 1 voltage source, 2 volts. In the circuit, I want to find the currents I1 and I2 and I, or the voltages of V. Okay, find voltage at node x. This is called x. Find voltage at node x. So simply you can find the voltages by using KCl. KCl at node x. KCL at node x. KCl at node x means, see, KCl means sum of incoming is equal to sum of outgoing currents. So this is x node. For this node, I ampere is current coming towards the node. That is, I is equal to, and outgoing is coming, the current which are going away from the node, I1 and I2. So I1 plus I2. So, and already you know the basics of current. Current always flows from the high voltage to low voltage divided by resistance. This is called voltage difference by resistance. Always I nothing but voltage difference by resistance. See, the current I is actually flowing from the battery supply to the node. So in this path, the current is coming in this direction, means 2 volts is higher. Why? Because 2 volts, because the direction is coming from the battery. The current is coming this battery, so it has to more than this voltage. If the current direction is coming from the V to 2V, the V has to more. Understand? Okay. 2 volts minus V divided by 1 ohm, because in this branch we have only one resistor. That's equal to, next I1 means in this branch only one resistor there and no another voltage source is there, only V is there. So V by 2 plus again in this branch V by 2. Take 2V minus V is equal to, take LCM, 2 plus 2 V by 2 plus V. So 2 is equal to, if you come this one plus 2V, so V is equal to 1 volts. See, actually total supply for this circuit is 2 volts. Among these 2 volts, 1 volt is appearing at this node, remaining 1 volt appearing here. This resistance consumes 1 voltage and remaining 1 voltage coming to these 2 voltages, these 2 resistors, actually these 2 resistors. Like this, the current, by using current law, that is KCL law, you can find the voltages at any nodes easily. So once you know the voltages at a node, we can find the currents. This is nothing but I is equal to 2V minus V by 1, that is 2 minus 1 by 1, that is 1 ampere. That is total current is coming from the battery. I is equal to 1 ampere, and I1 current is equal to V by 2, that is 1 volts by 2, that is 0.5 ampere. Similarly I2 also V by 2, again 1 by 2, that is 0.5. It is here also 0.5 amperes, these also 0.5 amperes. See, actually total current is 1 ampere. Total current is ampere coming here through 1 ohm resistance. When it enters to the node, the current equal divides 0.5 0.5 because there is equal resistors. So already you know the basics, that is current always divides the equal value when two parallel resistors are same. Okay, I hope you understand. I will tell you once again. KCL is all about currents. Sum of incoming currents is equal to sum of outgoing currents. That's it. And simply apply the current formula, that is voltage difference by R. If there is two voltages, if you have only one voltage, V by R. The circuit C at node, first we assume X and we assume voltage V. So sum of incoming currents is equal to sum of outgoing currents. So incoming current is equal to I, outgoing current is equal to I1 and I2. Similarly, we can write I is equal to I1 plus I2. From the circuit, I is flowing in this branch from battery to V. I is going from the battery, so battery should have high voltage than the voltage, like that, the one resistance. Next, I1 is coming in this branch. In this branch, I voltage is not present, only voltage there at the node V by 2. Again similarly V by 2. This is the KCL. Okay, KCL, already I said KCL is applicable for parallel circuit to find the voltage easily. By if you know the voltage, you can find the current directly. Thank you.